So welcome back, everybody. So this is James Hanslick, and he is with Clean Gulf Associates. And Monica's pulling this up. And he's going to be talking a little bit about remote sensing.
Just to kind of give everybody some background for me, I spent 25 years in the Coast Guard. Retired in 2011. I've worked with Clean Gulf Associates since that period of time. My background was oil spill response, chemical spill response. I was the operations officer here at the Gulf Strike Team in Mobile at one point, the deputy commander at the National Strike Force Coordination Center in Elizabeth City. And most recently in my Coast Guard career, I worked for Airborne at Robert, Louisiana at the Area Command. I was also the incident commander for a period of time in Homa. And then the FOSC for the spill in March through May 2011 before I retired. So I've kind of run the gamut as far as the deep water thing went. So I'm going to kind of give you an overview for remote sensing. I'm going to concentrate on vessels, and there's also an aircraft part of it. It just depends on how much time I have. So I'm going to kind of go through these fairly quickly so you can get a good taste of it. There's a lot of pictures. I prefer pictures because I'm more visual. So, okay. I have my clicker and it works.
Yes.
All right. Here we go. This was brought up when we had our discussion. Oil spreads on the surface in 2 dimensions. It's not evenly distributed. It's not just one little blob that sits on the surface. Breaks up into patches. The chemistry changes. It can emulsify, etc. And then what we do with remote sensing is detect, evaluate, and respond. So that's the big thing. These are some of the on-water environments that you could respond to. Okay, there we go. Offshore, nearshore, and inshore. Different types of remote sensings for those different types of areas, mainly because of the restrictions with if you're using aircraft, or if you're using drones, or if you're using vessels. Some areas you won't be able to get access to. One of the things when we're responding to oil spills, we're trying to increase our counter rate. If you look at the bottom of the little circle, you'll see a vessel this is during deep water. This is right at the surface, at the wellhead area. You can see that vessel transiting through the oil. What we're trying to do with the counter rate is increase the swath width and then the speed of the distance that's covered by that particular skimmer to make it more efficient. So we're using remote sensing. We're trying to increase encounter rates. When you hear encounter rate, that's what we're talking about. All right, so why use it? What we use it for is tactical spill information. We're trying to get information to the skimming vessels on the surface to tell them where to go and where to skim the oil. And then also that makes us more effective and efficient. We don't have to have as many response vessels out there, maybe because we know exactly where the oil is and where we need to pick it up. It also gives some georeference information to the command post so they can see it and they can go, oh, these guys are doing a good job, or these guys are not doing a good job, or we're documenting where the spill actually happened. And then again, you have the spill maps, and they just tell you the extent of the oil, where it is, and some of those things are used for legal things, natural resource damages, and others. So it's remote sensing becomes very important. So there's 2 types of sensors that we typically deal with. You have active remote sensing. That's typically the sensor pushes out some type of energy, and it's bounced off that item or whatever, and it's taken back, and it kind of gives that sensor a reading, and that's interpreted by software and other things to tell you what's actually going on. Passive remote sensing is whatever you're looking at throws off the energy and it absorbs that energy in some way or measures that energy in some way and puts it in a nice little package where you can actually observe it. Okay. Types of what we call types of remote sensing. You have 3 tiers. You have vessel asset type of remote sensing. That's typically mounted on a vessel. You also have Tier 2, and that's typically like a drone or an aerostat. It gives you a wider area of coverage, but not a large area of coverage, mainly to direct your vessels to respond. And then you also have tier 3, which is aircraft or satellite, that gives you the large picture, or maybe give you some tactical information depending on how fast you get the information to tell you where to go and to skim oil. These are vessel-mounted systems. These are the ones that we typically use. We have X-band radar. How X-band radar works is it looks over the surface of the ocean, and it looks at the dampening effect of the oil on the surface. So it picks up those dampening effects. But there are other things that create dampening effects on the surface. So when we're looking at an X-band radar image, it could be oil, it may not be oil. That's something that we have to go check out. So, and typically cameras are either IR or they're just digital images. On the top left, it's a digital camera. It also has IR, and it has also tracking and some other things. The picture that you see in the center there, that's a picture of some of the software that's actually used to give good information to the operator of the equipment. And it tells a number of different things. I'll go a little bit more detail. What we use at Clean Gulf is we use the Airborne secure system. It's a Norwegian system. It's used in the North Sea for quite a while. It's a nitrogen-cooled camera that you see off to the left. So it's more sensitive than an ambient air-cooled camera that you would use for IR type systems. So it's a military-grade type system. So it actually would pick up differences in thickness of oil once you're close enough to it. So, it has a great advantage over just an ambient air camera. That ambient air camera may say that there's something there, but it doesn't tell you the thickness. So you may be chasing something that you don't need to chase. We're trying to get to the concentrated areas of oil. So when we're seeing an ambient air camera being used, we may not see the thickness that we need to actually go out and skim. One of the other things that this particular system does, it georeferences everything. So when you're taking a picture, it shows where the vessel is in relation to the camera image. And when we take snapshots, it also tells the actual area where they are. So if you were going to take that information, you were going to put it on the GIS, you would actually know where that picture was actually taken. Up to the left is an infrared image of that this camera actually doing a response. I'll get into some more images here in a minute. This is a spill that happened 100 miles offshore, and nearshore areas it would be a similar situation. We got a call about 11:30 in the afternoon. Our vessels are fairly quick. They're 95-foot vessels. They go a little over 20 knots. We got out there that evening and started taking information. Now, our Aptamar system can also track other vessels that may be in the area. So when you're out there skimming, you don't want to run into somebody, or if there's someone out there that's also skimming, they may not have the same technology that you have, you can actually direct them to skim oil too. So that system works really well as far as that's concerned. Again, you have an infrared image to the left, and you also have a daytime camera at the top. So the way it works is you have your X-band radar. It tells you up to 20 miles off where you might see oil. You would go to that particular area, and then you would turn on your infrared camera, especially if you're at night, and that would kind of direct you to the area where you think is the most thickest oil. You also have a daytime camera that has a light on there. You can flick it on, and you can actually see what you're seeing to verify your IR is working or it's not working. So in this particular instance, again, you have the X-band radar. It's telling you where to go. You see some oil off to your left, and you get a little closer, and then it goes out. What's going on? Is that for me? Okay. So in this instance, white is the thicker oil, dark is the thinner oil. So in this instance, you can see some of the gray areas are the sheen, the thicker area is the actual oil, and that's what we're after. We're after the thickest part of it. So it almost looks like snow on the surface of the Arctic. It almost looks like an iceberg out there. So that's what we're going after. You see the lighter areas is what they're seeing when they took the video in this particular instance. It was about 1,900 hours. The spill was about 2,100 gallons. It was pretty spread out by that point in time when they got out there. Okay, we can go to the next slide. Next. So this is what it actually looked like on the surface during the day. So this is our 95-footer on the top and on the bottom. You can see the darker patches of oil right in front of the vessel, and on the top, right down the line. He hit the line and he's going to town. So and that's without aerial observation. At this particular one, they were already out there skimming. He took a picture of them actually skimming. So the system works as we thought it would be advertised. So we're fairly happy with it. So it kind of gives you an idea of some of the IR systems that are out there. Let's see what goes on after this. It also helps us with platform fires and other things. In this instance, there was a fire on a platform. We sent our vessel out there in the middle of the night to go take some video pictures. There may have been a spill associated with it. In this instance, there wasn't. The difference between having an IR system and before MC 252, we would have to wait to daylight hours to actually skim. Now we can skim at night. This is a video. It's kind of broken up because it's going over the airwaves. You can see that little bright area. That's where the fire was. It was a generator that was on fire. The good thing with these cameras is when it's not zoomed out, it's gyro stabilized, so you don't see a lot of movement. Once you zoom in, though, it's amplified. So any movement on the vessel is amplified. So okay. At this point, the fire was raging going pretty well at this particular point in time. We had some salvage assets that came out, and they actually put the fire out. And we got some video of them actually spraying water on the fire. It's not playing as well as it does in real life, but
it's really cool.
Kind of gives you an idea. This is how it would actually work if you were trying to stream it from offshore. Okay, that's what it would look like. So limitations on vessel systems. Typically, they're passive sensors. The electronics on those systems can be damaged in marine environments fairly easily, so they take a lot of maintenance. We're always looking at our systems and trying to improve them. Height of eye, the IR camera is only as good as the height, so you're only looking at 1 to 3 miles with the IR system. The X-band's a little bit better. Ambient air-cooled cameras aren't as robust as the nitrogen-cooled cameras, so their sensitivity is a lot better, so they give you the thickness. You keep your oil in the skimmer. X-band radar can produce a lot of anomalies, so you can be chasing a lot of things that you probably don't need to be chasing. Trained operators are a big deal with us, so our guys have had a lot of experience using the system, so they kind of know when they see a false anomaly or they think there's something that's out there that shouldn't be. Photo documentation is another big thing. Command posts, those people want the images as soon as possible. You're offshore 100 miles, send it by satellite, you're looking at 11 minutes to send one photograph. So it doesn't happen quickly, so that's a kind of a bottleneck in the system. But you can see at the bottom, for an IR passive camera, IR active camera, the differences in range detections. It's quite a big difference, 12 kilometers versus 20 kilometers for an active IR camera. So, and this is the system that we use. Okay. I'll quickly go through this. How much time do I have? 10 minutes? 5 minutes? Okay. Aircraft remote sensing is something that's been used for quite a bit, but nobody has a system that has 7 different sensors on it. This is one of the aircraft that's new to the Gulf of Mexico. It's a privately owned piece of equipment. It's been very, I've seen some, well, I'll show you some stuff. Here we go. Sensors on this has a number of different sensors. It has IR, UV, I'll get into it. This is they happened to be flying over the Taylor site when they were doing an overflight. They were just doing some training, and there's an active spill going on, and this is something that happens quite a bit. So they ran into this spill, so they start with SLAR first. That kind of gives them an accurate anomaly. Where's the anomaly? Where is it? And they could do this through clouds. You know, it's a very robust system, and it's an active sensor. This is actual spill. I'll talk about the laser fluoral sensor. It actually tells you the thickness and the oil type. The oil type is very important because you could be going out there to look at a platform, and if it's diesel, it's probably not from the platform, it's probably something else. Typically they have crude oil that comes from platforms, but on occasion you can have diesel still, but typically you'll see a light crude, so if there's an incident out there from a platform, you're looking for crude, you're not looking for diesel. So it's very important to have something like that. It also has a visual camera on there, digital camera, so they can actually take photos of what they're looking at while they're out there. So they get the visual on it, and then they start running the passes with the different sensors that they have. This is the SLAR image. It's that little dark area where the aerial is. These are the different sensors. There's a microwave radiometer that's not listed on here, but going to the left is UV, and then the IR to the right, the visual area, and then the laser fluoral sensor. So it documents exactly where the oil is, how much they can actually calculate from that with the microwave radiometer. They can calculate what the actual spill extent is and how much is actually out there. Tell you what type of oil it is, and then of course where it is. So if you had an active vessel out there that could actually skim in that particular area, it would have to be a certain thickness. You would know before you actually sent the resource out there to whether it's recoverable or not. So just in that, the use of that particular system, you can save money by not sending stuff out to respond to spills that are of no consequence, or you're sending a resource out there where you can actually recover some more. So in this particular instance, the aircraft, the biggest limitation with this aircraft is weather, ceiling, can they fly, can they take off, can they land. Depending on the type of spill, it could be the most expensive option because you're talking about a lot of money per hour for that particular aircraft. As far as safety goes, you're putting crews on a plane over the ocean. There's some safety involved with that versus a satellite. You're just flying satellite. There's no individual on there. Most of the aircraft that are out there right now are limited in the number of sensors that they have. For instance, during Deepwater, we had the Dash 8, had a couple of sensors on there that would tell you that there's oil there, but wouldn't tell you how much oil, wouldn't tell you the thickness of the oil. So it was just basically telling us that there's the oil there. We couldn't really actively use that to tell us where to put equipment to actually skim. This particular aircraft that I just showed you would actually tell you what type of oil is out there, where it is, and how much it is, and where you need to send your skimmers to actually skim. So from 2010 to 2000 and now, there's quite a big difference in where we are. I think that was my last slide, if I'm not mistaken.
He keeps going to sleep, I think. I think that last
Oh,
one's
yeah.
going to sleep.
Oh, this one.
Yeah, I think that one
So the other thing with this aircraft, which was, I think was like the best news that I heard, is that it actually has what they call a marine band radio on it. They can actually send IP information while it's actually flying, so they can actually send you the data while they're flying as they're capturing it. So with just a minimal processing time, they can send you that, or if you're out there on a vessel and you're skimming, they can send it to you via satellite, so you would actually get the information that you need to actually skim. So as far as a oil spill response thing, I would say this aircraft is kind of a game changer in that way, in the way that the IR system is a game changer, that you can skim at night, whereas typically would send a skimmer out until the first light, because you send them out there, they're not going to know where to skim the oil. So now it doesn't matter what time it happens, you can send the vessel out at any time. So those are the two kind of big things that has happened, as far as remote sensing goes over the last 5, 6, 7 years. So. And I also have a slide on here. You guys can actually download the information if you want. There was a presentation by Ian McDonald he did a lot of work with satellites. I didn't get into the satellite portion of this. And then also NOAA did a workshop here a couple of years ago on oil observing tools through the University of New Hampshire. And a lot of that information on there, different types of sensors and what they do, was listed in that workshop. So you can kind of get an idea what's out there. I can tell you from that Phototerra aircraft, there's nothing like it. I mean, you would have to put up 2 or 3 different aircraft to get the same information that this one aircraft does. But you would have to land the aircraft, process the information to get it where it needs to go. So it totally changes the mental